Hello, everyone, and welcome to another Jakarta Tech Talk. Joining us today, we have Steve Millage to discuss Jakarta Concurrency and what's next. Steve is the founder of Payara, an open source software company which gained large market recognition and blue chip customers within its first year. And if you have any questions for Steve as we move through today's presentation, feel free to ask it in the chat or using the Ask a Questions tab at the bottom. So without any further delay, Steve, it's over to you.
Thanks. As we said, we're basically going to be talking around Jakarta Concurrency, present and future. I'm normally the project lead of Jakarta Concurrency, specification under Jakarta EE. So as project lead, my goal is not to define the future of Jakarta Concurrency, but is to try and build a community group that can drive the specification forward. So basically part of that is this presentation, and we're starting to do other presentations to different groups to basically help people to get involved. So what I'm going to cover in this tech talk, I'm going to look at basically why do we need Jakarta Concurrency. I'll talk a little bit about the past of Jakarta Concurrency, some of the main use cases for Jakarta Concurrency, and where do we want to go with it. So we'll basically look at the main components, and then we look at futures, and then I'll talk a bit about how specifications evolve in Jakarta EE working group, and how, as an individual, you can get involved and help shape this API. Okay. So first, kicking that off is basically why do we need Jakarta Concurrency? So we look at what it is and some of the key use cases. So Jakarta Concurrency came in Java EE 7. So obviously it's part of Java EE and J2E before that. It's obviously Jakarta EE, J2E, Java EE has been around for 20 odd years. It's got a lot of longevity due to the stability and the use cases that it solves for developers when building enterprise applications. Jakarta Concurrency came in EE 7. There wasn't any changes to it in EE 8, and then since Java EE 8, we've been moving into transition to the Eclipse Foundation from the JCP. So in August 2017, I'll just talk a little bit about that transition. So in August 2017, Java EE 8 was released, and that had Jakarta Concurrency 1.0. And since then, we've been moving the whole set of specifications over to the Eclipse Foundation. The first release at the Eclipse Foundation was Jakarta EE 8 in September 2019. And from a Jakarta Concurrency perspective, that was exactly the same as Java EE 8. The goal for Jakarta EE 8 was to release all the Jakarta specifications that were equivalent to their Java EE ones using the Eclipse Foundation process. Key reason being that we could release them under different license, different specification license, different TCK license. But in all of the ways binary compatible. So if you got a Java EE 8 application, then it will run perfectly well as a Jakarta EE 8 application. The next stage of transitioning Java EE over to the Eclipse Foundation was the move to and release of Jakarta EE 9. This was obviously completed December last year. And what this did is it moved everything to the new Jakarta namespace away from the JavaX namespace. The JavaX being a copyright of Oracle, the new namespace was required, to release these APIs from the Eclipse Foundation. And similarly for that, as part of that, Jakarta Concurrency was migrated from JavaX to the Jakarta namespace. And that was completed on December 2020. And then very recently this year, May 2021, Jakarta EE 9.1 was released. And this effectively is like a minor update to bring all the test suites and everything up to JDK 11 to provide effectively provide compatibility with JDK 11 in the sense that you could run the TCK and prove your product was Jakarta EE 9 compatible on JDK 11. So again, Jakarta Concurrency was updated to basically bring it up to EE9, just using the namespace, and then there was no really changes for 9.1. The reason I'm sort of saying that is really to set the context that once we've done this transition, which we completed in May 2021, we're now in the point where we will need to evolve and basically innovate and move forward these specifications like Jakarta Concurrency. And that'll be looking forward into EE10. And so in this talk, I'll really cover some of the ideas that we have for EE10 and take you through those. So Jakarta Concurrency, as I said, was introduced in JavaEE 7. It was originally called JSR 236, Concurrency Utilities for Java EE. And if you want to use it directly, it's had new Maven coordinates from the JCP coordinates. So they've obviously moved to Jakarta. And for Jakarta E8, which is still in the JavaX namespace, it's version 1.1.2. And for Jakarta 9, it's version 2.0. So what is the goal of Jakarta EE concurrency? So it's mainly, the main goal essentially is to provide simple concurrency primitives that are very similar to the Java SE primitives and that you can then use within a Java EE application server. So one of the key things when you're using the application server is that you need to retain a level of context for your application when you move between different threads. So, for example, you would need to create, if you've logged in through like a REST API and you need to then kick off a task on a new thread, then you need to retain that security context. And what Jakarta Concurrency does is basically provides you with those application components. Like, so you can use the Java SE equivalents like managed executor, thread factories, and things like that, but use them in a way that is compliant with Java EE and Jakarta EE. So what it should allow you to do as a Jakarta developer is actually use those sort of concurrency primitives in a way to make and build more concurrent applications. It's actually a very small specification, pretty fundamental. It doesn't have dependencies on many other specifications. It's simply about building concurrency primitives that you can use within a Java EE application server. So just to explain that a little bit more, so in a typical application server, what you do is you provide your application, which is written to the Jakarta EE APIs, which is that jigsaw on the top there. And then you take that application and you deploy it to a Jakarta EE application server. And what the Jakarta EE application server or runtime is doing for you is it provides a lot of services. So it obviously provides threads, so thread management for you. It manages that pooling of threads, executing threads based on HTTP requests and other resource management around threads. It also provides security. So, you can just declaratively say that you require a role or a user to be in a role to execute a specific EJB call or something like that. And the application server runtime provides that for you and all the security checks. Again, it also provides, not shown here, provides class loading and application isolation if you deploy multiple applications. And it provides you logging, access to messaging, MIT metrics, all the network handling. But the key point is that it's a completely managed runtime for you. You as a developer, you program to the Jakarta EE or MicroProfile APIs. You package your application up into a WAR file or an EA file or a jar file, depending on what you have in it. And then you deploy it into the app server, and the app server runtime manages your application and the context that it runs within. And this is key when you, for example, if you wanted to say in your application, just spawn a new thread. If you did that using Java SE primitives, then the problem you would have is the application server is just completely unaware of that new thread, and therefore struggles to add context to that thread to make sure that all the components of the managed runtime can work correctly. For example, as I mentioned, the security. So it struggles, you wouldn't be able to establish a security context on that newly created thread, class loader context, or if you were in CDI, other contexts like that. So there's a whole bunch of context information that application servers maintain for you that allows you as an application developer to basically concentrate on the business logic and not worry too much about the cross-cutting concerns like security. And essentially Jakarta Concurrency, as we'll see, solves that problem for you. It allows you to use an analogous concurrency primitives to the Java SE ones, but maintain and retain all the context that you require. And so I'll go into some of the use cases and a little bit of the code, so you can see how currently what you can do in Jakarta Concurrency. So a very typical use case is basically to add an asynchronous break in your application. And if you've got old applications that were built maybe before JavaEE 7 and before Jakarta Concurrency came along, or applications that were built where people were totally unaware that Jakarta Concurrency existed, many people used to build an asynchronous break into their application using JMS. So many years ago, I was a consultant in the field, and I used to see this sort of this pattern used a lot. So, for example, imagine you have an HTTP request. It's coming into a servlet or a REST endpoint or something like that in an older application, and you wanted to kick off a long-running action. Perhaps you wanted to do a search on behalf of a user, so you wanted to return the HTTP request back to the user response, and then you wanted to do some work in the background in a long-running action. So before Jakarta EE concurrency, typically people would then, what they would do is they would package up the details of the request, push it onto a JMS queue, then build a message-driven bean that would take the data for the request, process whatever it needed to do, and then return to something, either store something and it results in a database for a later request or something like that. So you see this a lot in many Java EE applications, and some applications I saw in the past, this was the only use they had for JMS. They were just using it to build asynchronous breaks in their application. So, and obviously that's very heavyweight. And this is what Jakarta Concurrency was created to solve. So using Jakarta Concurrency, then it's much, much simpler to build this asynchronous break in your application. Basically, if you've got an HTTP request coming in, what you can use is just like you would use in Java SE, but using a Jakarta Concurrency version, you can run a managed executor service to submit a job onto that, and that will run within a managed thread, your long-running action, which replaces your MDB, and that would run on a executor service thread. But the key difference using Jakarta Concurrency API rather than Java SE is that that thread will be managed by the Jakarta runtime, and therefore will have the ability to apply the same context that you had in the REST request. So the same users, the same class loader, all the same context to use all the Jakarta EE injection, etc. Within that action, something which wouldn't be possible with Java SE. So this is obviously much more lightweight. So in code form, it would look something like this, and it is very much similar to, say, code you would use if you were going to do it on Java SE. So we have a simple REST endpoint. We got a get on here, and basically what you do is you inject your managed executor service, which has the same API as the Java SE managed executor. Sorry, same as the Java SE executor service, and you would submit a runnable to that, and you can obviously use a Lambda as I'm doing in this example. And that would basically submit it into the executor service thread pool. One of the threads would pick it up, establish your Java EE context or Jakarta EE context, and run your runnable. So that is really, really simple code, way simpler than using JMS and things like that. So another typical use case would be if you wanted to run tasks in parallel. Now, before Jakarta Concurrency in Java EE, this would be really quite tricky thing to do. But with Jakarta Concurrency, it's quite simple because it follows the standard Java SE primitives. So you've got a REST request coming in. You basically want to run 2 tasks in parallel and then maybe merge the results and return them to a user. So you can run, maybe gather information from different remote services. For example, maybe you will need to make external REST requests, correlate and collate the results and return them back to the user. So how you would do that in Jakarta Concurrency is again, you would just, as we did previously, it's missing from the slide, but you would inject the managed executive service into your REST endpoint, and then you can use the managed executive service API to submit 2 jobs at once, and you get back a future, and then you can merge it back together by calling get on the futures. And you could return that back to the user. So without using Jakarta Concurrency, if you did that with JMS, that would be incredibly difficult to do, as you would need to create correlation IDs to send messages over and return, and then listen on another queue, return the result, and then correlate it with the correlation ID and do the same for the second request and merge them back together by listening on a correlation ID. So that would be extremely advanced. So these sort of things typically don't get done in Java EE applications, but since Java EE 7, then we've had Jakarta Concurrency that can do that. So it's very easy to submit tasks and merge them back together again if you want. Again, as I said earlier, both of those requests, those 2 lambdas, will be running in the context of the application server and the originating request, this REST request. So security context, things like that, are propagated to your code, so you can use all the Jakarta capabilities. Okay, so another use case you could use Jakarta Concurrency for is running periodic tasks. So, for example, if you have a REST request comes in and you want to schedule some periodic tasks, perhaps it's some sort of polling of some remote service, or it's a job that you need to run on a fixed schedule by date or something like that. And you want that task to run in the same context as the request that basically created the task. Because Jakarta Concurrency effectively creates a managed version of a standard Java SE scheduled executive service, you can use the same API as you would use Java SE and submit and create periodic tasks or basic runnables that can run on whatever period you wish. So again, you could start that at deployment time if you needed to. And those tasks, again, would run in the same context, same class loader as the task that created them. Obviously, before Java EE Concurrency, you could only do this with EJB timers. So you would then have to create an EJB timer, set up either a programmatic timer or a timer based on annotations, and do that through using EJBs. However, if you don't want to use EJBs, you just want to use CDI, then there would be no way to do it. So EJB timers would be the only solution to satisfy this use case. Okay, so these are obviously there's many different other use cases for using threads and things like that, but these are some of the typical ones that we see. And what I'll do now is I'll go into some of the main components of the existing API and show how you can use them in different contexts. So as I said, it's quite a small specification. It's quite simple. It's quite easy to get your head round. So basically, the first piece of it is managed executive services. So what these are basically analogous components that map across to their Java SE equivalents. So in Java SE for threads, we have executive service, we have scheduled executive service. In Jakarta Concurrency, we have two analogous services, one called Managed Executive Service and one called Managed Scheduled Executive Service. And these have the same API as their underlying SE versions. The key difference really is that when that task gets run, it's run in the context required for a Java Jakarta EE runtime. And in addition, as we saw in the code earlier, you can inject one of these into a Jakarta EE component. The specification also specifies that there must be a default instance of each one of these, has a standard JNDI name, and if you inject it directly into your application, then you'll get the default instance of these two services. You can also create additional ones. So if you needed to sort of do more fine-grained thread handling within your application, run different tasks on different pools, then you can actually create additional instances currently with Jakarta Concurrency. The only way to do that, though, at the moment is you have to do them through your application's administration consoles. There's no standard ways to deploy different configured executive services. And I'll talk a little bit about that in the futures section of the talk. The other thing you can add to one of these services is a task listener, and basically that's a callback API. So you can attach it to the executive service or the task, and your basically application will get called back when the task gets scheduled and when it's complete. The other thing you can add on to a scheduled executive service is something called a trigger interface. Again, what this is basically the executive service calls back to this trigger interface to request whether it can run the job or the task. And this allows you to create programmatic timers, in other words. So you could write business logic as to when and whether a timer should fire, or sorry, a scheduled task should be executed. So it gives you a lot of flexibility over the rules on when a job can be fired. For example, it could depend on some other information in a database or anything else, or just on some time, some business logic time, rather than a straight type cron job. So this is one of the basic components. As I mentioned, these are analogous to the Java SE ones. So if you've used the Java SE ones, then you can use these. So obviously, if you were submitting jobs through managed executive services, you have control of when and the API of when you want to create thread pools and when you want to submit tasks. The concurrency spec also adds some primitives, which I'll talk through, which allow you to then integrate managed threads with maybe libraries that have no knowledge of the Jakarta concurrency specification or APIs. So for example, we have a analogous component that's analogous to a thread factory in Java SE called a managed thread factory. And this can be used when you have an API or you have some code that creates its own executives or something like that, but has no knowledge of Jakarta EE. So it's possible that you can pass in a thread factory. For example, if the API gave you access through a Java SE thread factory, then you could pass in the managed thread factory. So example in this code, ignore the rest parts of it, but you can see the call executives.newfix thread pool 2, passing a managed thread factory. That's a standard Java SE API. So managed thread factory basically gives you a hook to call into APIs that are not aware of Jakarta concurrency, but do take a thread factory as a parameter. And what the managed thread factory does is whenever a thread or task gets created to run on the thread, then it sets up the correct context again. So you can basically set up your Jakarta EE context so you can run this component in that thread within a Jakarta EE runtime and have all the services that you require. So that's one layer of lower API that's provided by the specification to get into Java SE or application or libraries that aren't aware of Jakarta EE. There's another. Sorry, I'll just go back to this one again. The other thing to note is that you do get a default managed thread factory, so you can just inject it as a resource. There's an even lower level component which you can use again for application frameworks or libraries that aren't aware of Jakarta EE but are spawning threads. And this is called the context service. So what the context service is it enables you to basically wrap your runnable. So for example, imagine if some library, you could submit a runnable to it, but you had no hooks into the actual thread handling or thread creation. Then the context service allows you to create a contextual proxy. So in this code below, again, ignore a little bit that it's a REST because it doesn't really matter, but you can inject the default context service. You create yourself a runnable. So there's a runnable here. And then what you can do is using that context service, you can create a contextual proxy. So what that does, it will create a proxy to any runnable, and then you can submit that proxy onto any raw thread. So if the API was basically just going to take a runnable, then you can submit your contextual proxy to that API. Basically, what that proxy will do is will establish all the context that you expect before it actually calls your runnable code. So basically, it will, when run gets called on it, that contextual proxy will set up the security, set up the class loaders, set up all the other services that you need to run Jakarta components and use injection and things like that, and then basically tear it all down again when your run exits. So you can use it against any raw thread and make that thread, in quotes, managed. So that's what you can do with a basic API as it stands now. So Jakarta EE8 and Jakarta EE 9.1, those are the things you can do. And as I mentioned earlier in the sort of setting the scene at the beginning, where we are on the journey in transition from Java EE to Jakarta EE is that we've now completed the release of Jakarta EE 9.1, which means the initiative now has, a whole specification set for a whole of the Jakarta platform released supporting Java SE 11 and in the Jakarta namespace and with all the TCKs and etc. So now we're at this point where we're looking to the future and we're looking to build Jakarta EE 10 and get that released, sometime late this year, early next year, depending on what happens with what people need to implement. So where we are, what that means for Jakarta Concurrency as a specification is that we've now just about starting the future work on what do we need to do to move this API forward. And part of this talk really is to encourage people to get involved and help us shape that. I don't want to think of everything that needs to go in there. So basically, if you're interested in Jakarta, you want to shape it, then get involved. And again, I'll cover more about that. So what I'm going to do in this section is basically talk about some of the ideas that we already have. These are on GitHub. These ideas, they're basically GitHub issues. But I'll take you through them one by one, and then I'll talk through about how to get involved and shape these. So the first one is deployable managed objects. And as I mentioned, by default, the current Jakarta concurrency specification says you will have a default managed executor, a default managed scheduled executor, a default context service, and a default thread factory. To create additional ones configured differently, you would need to use the tools of your application server. For example, in Payara, you go to the administration console, you can set up a different managed executor service, and you can give it different thread pool settings, and you can give it a JNDI name, a JNDI name. So moving forward into the sort of patterns of how you would do this to make it aligned with other things that you can do in Jakarta EE 8 and 9 is, we have deployable application scope data sources, in Jakarta EE 9. So what we're suggesting here is a feature whereby you could have application scoped and configured managed executor services, or basically all of the components that we have in the specification, and you would deploy them with an annotation. So within your application, for example, you could set up your own managed executor definition, something like this. This is an idea, it's not set in stone. You would set up the JNDI name for it. You would set up what context service it uses, and maybe the size of your thread pools, minimum concurrency, min threads, max threads. And what this will allow you to do, if you've got an application that really needs to have fine-grained control of the concurrency, the threading, the pooling of threads, maybe you have jobs that need to be on one thread that needs to be separated from things from different thread pools. So you've got one maybe for long-running jobs, one for very fast. Then it would allow you as a developer, without having to use administration consoles, to set these up. So you could attach this annotation to your component and then use that and inject it and use that to submit jobs. You may need to do that if you need to make sure you're preventing deadlocks or live locks in a very highly tuned system. So that's one of the things we're looking at. Another idea is basically a new schedule annotation. This would be like the EJB timer annotation, but you could use it for other components. For example, you could attach it to a CDI bean. So the idea would, here's an example, we'd have an application scope CDI bean. You could add a schedule annotation. You could specify the name of the executor service you want it to run on, and then you could give it some sort of cron type command or a trigger class or something like that you could use to basically ensure that 5-minute rule method is run on a specified schedule. We could also extend that maybe into look at some persistence, like obviously you can, in EJB timers, you can have persistent EJB timers, and we could also look at whether and what the semantics are in a cluster. For example, the EJB timer spec says that the timer fires only on one node in the cluster, and perhaps we could look at specifying different semantics than that, or have that as one of the rules on a cluster. So we could have it fire on all members, or just fire on one member, or something. Things that we could expand and look at. But in the most fundamental, we'd look at creating a schedule annotation. Okay. Another one we're thinking about is an async annotation that is generic. So currently there are async annotations in Jakarta EE, but they're quite specific to each individual specification. So for example, EJB has its own, the REST client has its own, Jakarta REST has its own, Jakarta Servlet has its own. And perhaps we could create another one in the first instance, but that could be also used with CDI beans. So for example, we could have an application scope CDI bean using async or asynchronous, depending on what we decide. Give it the name of the executive thread pool that you wanted to run it on, and then create async methods. And again, adding and being able to configure executor service pools would basically enable you to control the concurrency management of your application. So you could choose different thread pools for different methods and those sort of levels of detail. So once we had this annotation, then we could do quite a bit of work. I think unlikely to happen in EE10, but in later on we could start to remove some of the asynchronous annotations from other parts of the Jakarta EE platform, and actually try and concentrate onto a single annotation, maybe provided by Jakarta Concurrency, which would then be common to all the specifications that they would all build on. so that again we sort of simplify the platform and make it a little bit more unified. And again, if we did that, then you'd be able to specify the thread pool for an EJB async method, or a servlet one, or a REST one as well. So that would bring in simplicity to the platform. Okay, there's a whole bunch of work we need to do around catching up with java.util.concurrent. As I mentioned, Jakarta Concurrency was released in JavaEE 7. So it hasn't really been brought up to date to match a lot of the concurrency primitives that came in Java 9, and that obviously been built on in Java 11 and in Java 17 that will be coming. So some of the things we need to do around here, we would need to support the fork join pool in a standard way. So we could create managed fork join pools, and that would allow that would basically enable anything that was using the fork join pool to potentially be usable within an application server and with the correct context. We also need to update the APIs to match current Java SE managed executor and managed scheduled executor executor service and scheduled executor service APIs in Java SE. So we need to add in support for completable futures and do some work like that, just to make sure that we do, again, map to directly across, analogous to the java.util.concurrent APIs. Okay. Then there's another big piece of work around alignment with MicroProfile, and some of the initial PRs have been done for this. So MicroProfile, during the transition from Java EE to Jakarta EE, MicroProfile sort of picked up some of the innovation work required to move Jakarta EE forward. For those that don't know, MicroProfile is a similar initiative within the Eclipse Foundation that is building new APIs on top of Jakarta EE APIs, specifically for sort of microservices type architectures. But some of the work that was done in MicroProfile around context propagation was sort of done because Jakarta Concurrency was stalled, if you like, as it was moving through the transition period. So this API has already done MicroProfile context propagation API, has already got introduced APIs to completable futures, and also provided APIs to capture contexts and run that into completion stages as well. So there's a whole bunch of work there that we need to move into Jakarta Concurrency, and that'll do some of the work required to map back onto the latest Java SE APIs. Then, as I say, there's a whole lot of stuff that it's probably more longer term, but we need to align the whole Jakarta EE platform to make it a little bit more simpler and not reinvent things in different specifications. So some of the things I'd like to do to make Jakarta EE a bit more consistent for people, a bit more simple, is some platform alignment. So the first one is make Jakarta Concurrency work well with CDI, and some of the things we've sort of suggested, like asynchronous annotations, schedule annotations, etc., they would all support CDI. MicroProfile context propagation has done quite a bit of work on this as well, and so that's an obvious thing. CDI is obviously now fundamental to Jakarta EE. The problem is it came in quite late, so some specs don't really integrate with it at that point in time, and that needs to be fixed. Incorporate into the web profile. I think in the last couple of weeks that's been agreed. Web profile currently doesn't have Jakarta Concurrency in it, which is a bit crazy given it's essentially a fundamental threading API and has nothing, there's nothing complicated about it. So that one's been agreed, and that's moving forward. As I say, longer term, I'd quite like to re-implement EJB asynchronous on Jakarta Concurrency and allow the asynchronous annotation on EJPs to specify which managed executive service you use, And that's same again with servlets and Jakarta REST. We could map those async annotations and move them onto Jakarta Concurrency. And then again, we'd also quite like to re-implement the whole of Jakarta Enterprise EJB timers onto Jakarta Concurrency. And then it would also support not just EJBs, but it'll support any managed component, like any bean, like a CDI bean. And again, allowing you to specify what managed executor service you want to use to do fine-grained. And then there's a whole load of internal cleanup that needs to be done and a little bit of evolution. So the first thing is, as I said, Jakarta Concurrency came in EE7, so it was targeting Java SE7, and therefore currently date-time APIs aren't in there. And obviously it's quite a simple thing to do, but we need to provide APIs that take Java SE8 date and time support, especially for things like triggers, and APIs that specify schedules, things like that. I mentioned earlier there's a sort of trigger class. This is something you can pass to a scheduled executor along with your task. And what basically the executor does is it calls your trigger class to see whether the task should run. And what we could do is provide some concrete triggers. So one example would be like a cron trigger, and something that Spring has for their equivalent to this API. And you'd be able to specify, a cron schedule or something like that, and pass it into the scheduled executor service along with your runnable. And we could think of others as well, but cron is the most obvious one. We need to standardize some of the configuration attributes. This is getting really into the detail. Something like thread pool size, thread min threads, max threads, things like that would need to be done. The API is a little bit abstract, so it doesn't necessarily mean they're threads, so you'd probably call it max concurrency or min concurrency or something, in case you wanted to do that. I mean, longer term, we'd also need to look at Project Loom and how we would work in Loom, but obviously that's unlikely to hit Java SE17, so it's not likely to hit our timeline for a while, but it's something that we need to look at and think about. So that's the sort of work we're looking at. What I'm going to do now is basically do a call for help. I said I'm the project lead, but that doesn't mean to say I specify what we do and everything that's implemented. Unlike the JCP, where you had an expert group and an expert group lead, the Eclipse Foundation is slightly different. A project is an open source project, and the project lead's job is there to basically make sure that project follows open source principles, but not to essentially be the leader or the guy who thinks about everything that needs to be done. So I'm going to do a little plea of how to get involved. First thing to note is what is involved in a specification, really. So there are a number of things that we need to produce as a project to have a Jakarta EE specification. So these are a specification document. So that is effectively an ASCII doc that gets generated into a PDF, which talks about how you use the API, use cases for the API, background of the API, things like that, how methods and things should be, what the behavior of them should be. Over and above what's in the Java doc. We have to create an API jar. Obviously, that is the thing that, as a developer, you would use and code against. That basically specifies what the APIs are. And the other thing we have to create is something called TCK. So the TCK is the Technology Compatibility Kit, and that is the test suite that proves that independent implementations of this API meet the requirements of the API and implement it fully. So the TCK would run against, say, something like Pyara, which has its own Jakarta concurrency implementation built into it. And what the TCK does is it tests that Pyara implements all that API correctly and in accordance with both the spec document and the API jar. So to release a specification from Jakarta EE, we need to have a spec document, an API jar, a TCK, and that's the responsibility of the Jakarta Concurrency project. The other thing you do need to have, which isn't on the slide, is you need to have a compatible implementation that is open source, well, not open source, freely downloadable, and that has passed the TCK. And that's really just a gating thing that proves that your API that you've created is actually implementable by somebody. So it's not something that nobody can implement and pass the tests for. So when it comes to this, we basically, if someone wants to get involved, we can get, you can get involved in each and every part of this. So if you're more interested in test suites and things like that, you could help build or tests or help maintain the TCK or make requests to that. And obviously the more broader and the more test cases we have, the better independent implementations will be, and the more portable implementations will be, and the more you'll be able to move your application from one application server or to another. You can obviously help directly on the API and shaping things like schedule or any things I mentioned, and that again is absolutely welcome to work out what would you want as a developer, what capabilities would you want in Jakarta Concurrency. And then there's also help needed around the specification document, and that could be just as much as submitting PRs for typos or anything like that. Any of it's welcome. So these are the main links of how you get involved. So the Eclipse project there. So we are an Eclipse project. We have a mailing list that you can use if you want to talk to the development team, but I mean, the development team is anybody, so anybody who subscribes to that can email onto that list. All the code is on GitHub. The whole project is run on GitHub. Every one of those features requests that I talked about, their issues on GitHub, and we can discuss them just by using GitHub issues. And then any API changes will result in a PR, and again, we can discuss it on a PR before it gets merged into the API code. Currently, there's a compatible implementation as well that is on the same GitHub organization. It's a slightly different project, but essentially it is an implementation of the concurrency API, and it's used in Glassfish and Payara, and it may be used in others as well. But so you can also, as I mentioned earlier, to get a specification released, then we need an implementation of the specification that can pass the TCK. And currently this is the one that we use. And that's on there as well. Code's on GitHub, and anyone can get involved with that. So I'd really encourage people, if they're interested in Jakarta EE, not just Jakarta Concurrency. The world changed when we moved to Eclipse Foundation. It's very easy to get involved. It's just no different to any other open source project. I know it can often seem quite scary to get involved in something like this and try and shape the industry, but we are really asking for people to get involved and help. So if you do have any desire to do that, then either just comment straight on GitHub, or you can reach out to me, and I'm always happy to introduce people and bring them in. I know when I first ever joined an expert group at JCP, it can seem a bit daunting. That the people are mega brains and may not want your input, but that's absolutely not the case. Especially I'm a big mega brain. So if you want to get involved, please do. And that's it. Thank you very much. And any questions?
Okay, so it looks like we have one question here. Could you please tell us more about the current integration of concurrency with CDI and EJBs? I've used them as tasks, but I always found it difficult to manage them due to their life cycles. Is this what you mean by further the integration with CDI in Jakarta 10+?
Yeah, I mean, CDI, because it came after or around the same, I can't remember the exact timeline, or similar time as Jakarta Concurrency, the two don't necessarily have any integration other than the context can set up some things to do that. What we're looking at when we're talking about deeper integration is trying to solve those problems, really, and look at it in much more detail and provide concurrency primitives to CDI, which don't currently exist. And MicroProfile context propagation has done quite a bit of that work, and we're bringing that work into Jakarta Concurrency.
Okay, awesome. Thank you. I don't see any other questions here, so I just want to thank you again for that excellent presentation today, Steve. And just a reminder to everyone in the audience, if you do have any final questions, you can just throw them in the tab now while I wrap up. So the next Jakarta Tech Talk is happening August 30th with Santiago Gerstein, as he joins us to present the preview of Jakarta REST 4.0. And you can register for that session using the link here. And we're also looking to book more Jakarta Tech Talks through the fall and the rest of 2021. So if you're interested in presenting, we have the sign-up sheet here in the chat. And finally, if you have any feedback on the Jakarta Tech Talks, we would love to hear it from you. So I'll just put it, there's a green button at the bottom. So if you could fill that out, that'd be super helpful. And I'll just check and see. I think we have one more question here. Yes. What kind of profiles is the Eclipse Foundation is mostly looking for at the moment? Mostly developers.
I think it's anything really. If you want to get involved, I would say everybody is looking for people to get involved at all levels. If it's development, yeah, absolutely get involved. If you have strong views of how Jakarta EE should develop and evolve as a developer, a Jakarta developer, absolutely. But it's not just that. I mean, the whole Eclipse Foundation working group is looking for help for promotion, for talks, for tech talks. If it doesn't have to be just project leads that do tech talks, I believe. Anybody can. And I say updating documents, writing tests, or just providing blogs or something around concurrency. I'd encourage any of it. So
awesome, thank you. And it doesn't look like we have any other questions, so I'd just like to thank you again, Steve, for this presentation, and thanks everyone for attending, and I hope you have a great rest of your day.
Thanks, everyone.
Thank you.